ready to teach you guys about or talk to you guys about Gaussian splatting. Has anyone heard of Gaussian splatting before or ratings fields? Okay, cool. So there's a couple of people here. So a couple of weeks ago was kind of big on AI, social media. Apple released a model to convert images to these 3D Gaussian splats. And Gaussian splats aren't new. Apple's not by any means the first company to do that, but their claim to fame was it was a one model image input, 3D world output, and it executed within just a very short amount of time, a couple of seconds. So they released it as a PyTorch model, and it's not necessarily consumer friendly to use on your different apps, but it's relatively easy, in general, to take a PyTorch model and convert it to CoreML. And CoreML, if you're building Apple devices, iOS, iPad, VisionOS, that's kind of the format that works best on your mobile devices. So that's kind of what this project is about. I took Apple's Gaussian splatting model and converted it to run on a VisionOS, and I actually have a VisionPro, but I forgot to bring it today. But if you come to the next Raleigh Tinkerers, I'll have it and I'll let you all try it out. So it's really cool once you see it in like the full kind of immersive environment. But if you have a PyTorch model, to convert it to CoreML, you can actually just use the Torch library. It's sort of a built-in capability. One of the key things that you would need to do is just to create a wrapper function that calls the inference mode of PyTorch. So if you've ever played around with PyTorch or TensorFlow, they have an eval mode for inference that sort of optimizes it for evaluations. And when you do that, you can more or less call the convert function of PyTorch, but there's a couple of key things you need to keep in mind if you're doing to CoreML. One thing is kind of managing your input resolution. Let's see, I can't really. It's really small there. So the model CoreML sort of requires kind of fixed inputs, so you would need to kind of scale your inputs to match the CoreML format. The other thing that's really important is naming your inputs and outputs. So by default, if you just call convert, it doesn't do this operation and it'll fail. Or it won't fail, but if you try to use it, the output layer names are going to be just gibberish. You're not going to know what's what. So you can give your output names, like this one has colors, opacities, quaternions, singular values, mean vectors, which are all kind of things that define what a Gaussian splat is. And then, of course, you can name your inputs, which in this case is image and disparity factor. That's really important. And when you call the convert function for PyTorch to CoreML, by default, it's going to want to use like the metal library for converting, but that's not actually going to work when you're trying to convert from PyTorch to CoreML. It just gets stuck in the cycle, and I let it run for probably hours before I realized something was broken. So you want to set the compute unit to CPU only, and it shouldn't take more than this is a 2 gigabyte model that Apple released, and it took about 10 minutes to convert it to CoreML. And then iOS 17, that's the latest target right now for CoreML outputs. And when you do that, it'll generate you a CoreML model. And let me see if I can get this. So originally I was going to show the VisionOS, but I'm going to try to, I created a local demo as well. I'm going to try to show that real quick, and then we can take a look at VisionOS. Okay, it's not opening, but you can, this is the Gaussian splatting. One of the unique things about them is they actually are really performant to run, and you can actually run them in your web browser with WebGL, and you get great frame rates. So this is one that I converted just a minute ago, and this is the VisionOS simulator. So this is kind of what you would see in the VisionOS, the headset. So if you look at this one, it's from my back deck, and one kind of interesting thing about splats is if you go to about the perspective of where the camera was taken, it looks exactly like the photo. It's a pixel sort of perfect representation. And that's kind of the perspective there. But because it's taking this 2D image and converting it to 3D, you can basically kind of go into the picture itself, and you can see it sort of degrades the more you kind of go into the 3D world. It kind of degrades a little bit, but that kind of helps you kind of see what the splat actually is. So once you kind of step out of the 2D perspective and you kind of go really close to one of these things here, you can kind of see this is essentially what a splat is. It's an ellipsoid with like a color and a shape parameter and a 3D position. And when you put them all together, this has 1.2 million splats that system is rendering. It looks like a photorealistic picture. So this process is actually to convert an image to this 3D representation. It's about a 10-second process on VisionOS, and it works basically on any picture that you can take. There's other sort of splatting libraries that work on what they call 4D splats, which is like a video sort of system where this representation will actually move. And I think that's gonna be kind of a bigger thing moving forward. And then I've got with the VisionOS, it actually has interactions to where you can actually use your hands and bump into the splats. I've got a video of that on the website. It's linked on the Tinkerers if you want to check that out. But I think the first splat renderer that I've seen that actually responds to your physical touch. The other thing was, let's see, I think I have one other thing to talk about with splats, but
What was the inference time for that?
it takes about 10 seconds to convert the image to 3D. Yeah, 10.
Is it running locally?
Lo-
The CPU of this laptop?
Yeah, locally, the CPU, the laptop, the VisionOS. You can actually run it in the browser because you can convert the model to Onyx as well. But the browser right now, both Chrome and Safari, they hit the model is a little bit too large. The 1.2 gigabyte model is too big for the browser. So let's see. Yeah, for this model, it only takes one picture input. But there are other researchers who have released ones that do multiple viewpoint model to do. Oh, that was the other thing. Because of the way the 3D system works, when you do that multiple viewpoint model, it's really good for things like potentially robotics. It could be a good input for like your world models and your action models, because it can take it can represent things volumetrically. Robots can see that this is actually a table that it needs to go around and things like that. So I think you'll see that use case for splatting become a little bit more common because it is a very powerful and fast way to represent sort of 3D world data with photorealistic accuracy. So yeah, hopefully next time if you all come, I'll have the VisionOS, and it's a lot more kind of cool to see when it's immersive in a one-to-one environment and you can kind of walk around in it. So it's pretty neat.